everything real quick. Okay. All right, I need everybody's attention, please, real quick. A couple things I want to talk about. I'm going to recap what we did yesterday, but I highly recommend that if you were not here yesterday, you go into Schoology, into the videos folder, and watch. It's in the sequences and series notes. It's a 30-minute video of me going over this. I'm going to go over it today in class. In last period, some of the kids caught on by the end of class. If you don't catch on by the end of class, you definitely need to go watch that video. Tomorrow, well, let me just look at this calendar real quick. So tomorrow is going to be a straight up homework day. Your homework is due at the end of class. So you're going to have the entire class period. You're even going to get to start it today. Have the entire class period to do homework. It's due at the end. And then on Thursday, we have the assessment. Your assessment is not going to take the whole time. It's only going to take 30 minutes. We're going to trade and grade, and I'm going to answer questions from the homework before that. Then on Friday, I know it feels ridiculous, but we are going to start a new unit for one day because some of those questions are on your Lone Star Final, and I need to make sure we go over it. It's not super difficult. We're not even going to take the whole class period. It's very quick. And I actually think I'm going to make that homework due. Yeah, I'll make it probably due Monday, but you will probably finish it in class. 1 week from tomorrow, you have day 1 of your Lone Star Final. I believe day 1 is no calculator, and day 2 you get Desmos, I believe. All right, and then on Friday you have a TEKS test in here, 20 questions, multiple choice. Oh gosh, most of them are multiple choice. I think that was number 15. And it's online. You get Desmos for the entire thing. TEKS test. We're not worried about that. Remember, that's an L-level test. All right. And then when we come back that next week, the last full week of school that's not with finals, we're finishing up conics because you have an assessment. Again, seniors, that assessment will be optional for you because you start exams that Tuesday. All right. So yesterday, we learned the binomial theorem. I want you to please look up day 1. The binomial theorem, what it is it's the formula so that you can expand any binomial raised to any power n that isn't positive integer. So in middle school, you learned anything to the 0 power was 1. And then you learned that if you have anything to the first power, isn't it just that same thing? And then in Algebra 1, you learned a plus b, anything squared, can't you just FOIL it to get a squared plus 2ab, right? So now what I am teaching you today is what if that exponent is 3 or 4 or 5 or 6 or 20? What are you going to do? So what we did was we learned the binomial theorem. Before I taught that, and again, at the end of class, you'll have time to copy this down, so I'm not going to have you copy it down right now. I'm just going to have you watch. So with that binomial theorem, if we have x plus a to the n, here are the different n's. These are the coefficients in front. Again, don't worry about writing that right now. All right, and so we learned this was called Pascal's triangle. And what's cool about Pascal's triangle is look up, what is 1 plus 3? What's 3 plus 3? What's 3 plus 3? Okay, cool. What's 3 plus 1? So the numbers above it, if you add them together, that gets you the numbers below it. All of these rows start off with what? 1 and end with 1. So they're always going to start off with 1, end with 1, and then you just add the numbers to get the next one. All right? We also learned that Pascal's triangle comes from the combinations of each of these. 0, choose 0. 1, choose 0. 1, choose 1. And different things like that. This right here is where Pascal's triangle is from. I don't need you to worry about memorizing this picture right here. I just need you to know that's also where it comes from. Now, what is a combination? You learned in geometry, or you were supposed to learn in geometry, that a combination has order does not matter, and what it does is it tells you how many different combinations of things you could choose. For instance, Baskin Robbins has how many flavors? 31 flavors. Let's say you wanted to choose, 3 scoops. What are the different flavors, what are the different combinations of 3 scoops that you could have? That would be 31, choose 3. So, what we love about combinations is you can use Desmos. By the way, you get Desmos on this assessment. So if you hit the functions button and go all the way to the bottom, this is the combinations button. There are 31 flavors. I want 3 scoops. There are 4,495 different combinations of ice creams that you could have. Okay? So that's what combinations is. So again, we're going to be using Desmos for that. And what we are going to be doing with that is this right here. I'm going to give you this paper in just a little bit, but this is your homework. So what it wants you to do is evaluate the expression. What is 5, choose 3? You can just go into your calculator and type in 5, 3. What is my answer? So the answer to number 1 is 10. That is how you do 1 through 4. However, on the second part, it wants you to write an equivalent expression. The equivalent expression is this formula right here. If you have n choose j, it's n factorial over j factorial, subtracting them. So, I have 5 choose 3 again. So what is this going to be equivalent to? 5 factorial over 3 factorial. And then what do I need to do? Subtract. What's 5 minus 3? 2. So this is 5 factorial over 3 factorial, 2 factorial. That is equivalent. Nope, you just leave it like that. Okay? If you want to actually simplify it out, we did that already. You just put that in the calculator. Okay? So this is evaluating, this is finding an equivalent expression. Factorial is when you do, and again, watch the video and it'll explain it more, but it's when you multiply the descending numbers from there. So 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And what I told them is, okay, what if I give you 20, choose 4? Are you going to want to do 20 times 19 times 18 times 17? Absolutely not. Put that baby in the calculator and move on. That's combinations. By the way, I'm summing up everything we did in 5 minutes. Again, if you're like, whoa, watch the video. So we ended class actually doing the binomial theorem and expanding these binomials out. So x plus 2 to the 5th, if you were to FOIL that out and distribute the 5 different times, this is what you get. We did the binomial theorem. So we're about to do that right now with example 6. If you were not here yesterday, what I would like you to do is start page 38, flip to the back and go to like the middle or the bottom and do this one with me. After we do about 3 of these, you're going to see a pattern and this will make more sense. All right? So if you can all please, everybody right now, do example 6 with me. We are going to expand 3x plus 2 to the 5th. Now what the binomial theorem says is your exponent is your n. So what is my exponent here? What's my exponent here, y'all? 5. So n equals 5. If n equals 5, how many terms is this going to have? 6. So yesterday we learned there are always one more than whatever the n is. 1, 2, 3, 4, 5. So this will have 6 terms. And we also learned that when you do the combinations, you are going to do 5. You're going to start with 5, choose 0. 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. And 5, choose 5. Now, my people that were here yesterday, After we do that, what do we do? Say that again, 3x what? So we are going to take our first term in the binomial, 3x, and it's going to start raised to the n power. In this case, 5. What's my next one going to have? 3x to the 4th. 3x to the 3rd. 3x squared. 3x to the 1. And then 3x to the 0 power. What do I do next? My second term. What's my second term? 2. In the binomial, the second term is 2. And what am I going to start off with 2? We're going to start off the second term at 0. Hey, by the way, look up real quick. These numbers will always be the same. So then what is this going to be? 2 to the 1. 2 to the 2. 2 cubed. 2, nope, I already did that, to the 4th. And 2 to the 5th. At the end. So 3x, so right here, the exponent, 3x is to the 5th, 4th, 3rd. So this one right here is, the first term is always going to be these two numbers subtracted. The second term will always be the same as that bottom number. And the top number is always n on all of these. Does that make sense? Okay. Now, we just go through and do the multiplication. Again, you're going to get Desmos. So you can do two things right here. 5 choose 0. You can either put it in the calculator or, y'all, do y'all see how n equals 5? Look at Pascal's triangle. These are your coefficients here. So you can either use Pascal's triangle or you can just use Desmos. So if I were to use Desmos here, I would do, what's 5 comma 0? 5 comma 1. 5 comma 2, 3, 4, 5 comma 5. Or you can look at Pascal's triangle. This is 1, 5, 10, 10, 5, 1. What is 3x raised to the 5th? 200, what? 43. Remember, it's not going to be 15. You have to actually raise 3 to the 5th. So it's going to be 243x to the 5th. What is 2 to the 0 power? 1. It just cancels them across it. Plus, we have a 5 out front. What is 3x to the 4th? 81x to the 4th. Do y'all get how I'm getting that? 3 to the 4th, x to the 4th. And then what's 2 to the first power? 2. Then we have 10 out front. What is 3x cubed? 27x cubed. And 2 squared is 4. Are y'all following along? Then I have another 10. What is 3x squared? 9x squared. And 2 cubed? Be careful. 2 cubed? 8. Oh, is that what you said? Oh, I thought you said something else. Then I have plus 5. I just have 3x because it's to the first power. What's 2 to the 4th? 16. And then do y'all agree 3x to the 0 goes away? And then I have plus 1 times, what's 2 to the 5th? 32. That looks like a lot. It looks kind of scary looking at it. But now you're just multiplying the numbers. So 3x plus 2 to the 5th is, what's my first term going to be here? 243x to the 5th. What is my second term here? 5 times 81 times 2 is what? 810 x to the 4th. What is 10 times 27 times 4? Say it again. Yeah, 5 times 81 times 2 is 810. Yeah. Can you say that louder? 1080. So 10 times 27 times 4 is 1080 x to the 3rd. What about 10 times 9 times 8? Five times 3 times 16? 240. And then 1 times 32 is... And we have just expanded this out using the binomial theorem. What'd you say? You get it? Yeah. So a couple things. First of all, do I have any questions? Can I answer anything about a step that I took? Anything like that? A couple things I want you to notice up here. Your n is always going to be the top number. Choose will always start at 0, 1, 2, 3, and you should end up with n, choose n. Next thing, your exponents should always add up to n right here. So you see how we have 3 plus 2, 4 plus 1? It should always add up to n. Okay? And just the biggest mistake I see is make sure you are raising that 3 to the 3rd. Don't do 3 times 3. Okay? Now, am I going to ask you for 3x plus 2 to the 20th? Yes and no. I might ask you that, but I am not going to ask you to expand the whole thing. So instead, what I'm going to ask you is just to find one term. So that's what we are now going to do. I'm going to flip over. If you have room, you can flip over, but if you don't, no, if you have room, you can keep going. If you don't, flip over. So here is, we're going to do example 7. So find the coefficient with in what? Please write that down. Find the coefficient with y to the 8th in 2y plus 3 raised to the 10th. Write this down. Okay, let's talk about this. Do I want you to expand this all the way out? How many terms would this have? 11. Because it always has one more than your exponent, right? It would have 11. Do I want you to expand out all 11? No, I just want one coefficient, and I want that coefficient with y to the 8th. Well, let's talk about this. If I do my first term, what would my first term look like? 10, choose what? 0. And don't you agree my first term would be 2y to the 10th? Do I want y to the 10th? No. What would be my second term? Wouldn't it be 2y to the 9th? Do I want y to the 9th? No. So I want this third term. Does that make sense? So I'm going to only focus on that. I'm not even going to worry about everything else. I am only looking at this third one. And this third one is going to be what? Wait, 10, choose 0, 1, 2. Does everybody see why that's 2? because it starts at 0. 10, choose 1. It's going to be 10, choose 2. Then my first term is, in the binomial, 2y to the 8th. My second term in the binomial is 3 to the 2. What questions do I have about what I just did? Do you see how I got that? Brian, happy birthday. Is it your birthday? Happy birthday. Sorry, I'm random. I know. I have it in my head all day to not forget, and then I always forget. But I didn't forget this time. All right, so what do I do now? How do I do this? 10, 2. Put that in the calculator. Don't be trying anything else with the calculator. So, don't do that. 10, choose 2 is 10, choose 2 later. It is 45. All right, cool. What else do I need? What else do I need to know? 2 to the 8th. What is 2 to the 8th? I don't know that off the top of my head. 256 y to the 8th. And then what's 2 to the 3rd? No. What's 3 squared? 9. And now what do I do? Get your answer. 45 times 256 times 9 is 103,680 y to the 8th. But what is the question asking for? Be careful. What's the question want? The coefficient. So what is my actual answer here? What's the coefficient? Just the number in front. If you were to put y to the 8th with this, you will get points off. Y to the 8th is not my coefficient. Put the number in front. All right, what questions can I answer about that? That make sense? Francesca, are you with me over there? I'm sure. Find the 6th term of x plus 2 to the 9th. Write that down, please. How do I find the 6th term of x plus 2 to the 9th? Okay, we're going to do kind of the same thing. So what I'm going to do here is I'm going to do, well, the 6th term is 1, 2, 3, 4, 5. I want this 6th term. Right? What's going to be my combination for this? What's going to go on top? A 9. A 5. Because 0, 1, 2, 3, 4, 5. That make sense? Yes. And then what's going to go here? X to the 4th. Why x to the 4th? You can subtract these two numbers to get that. Or you can say, hey, 9, 8, 7, 6, 5, 4. Subtract 9 minus 5 is. And then what's going to be the second term in my binomial is 2 to the 5th. Is this making sense? And then how do I get my answer here? What's 9 choose 5? 126 x to the 4th. And what's 2 to the 5th? 32. And what am I going to do here? Multiply. So I'm going to multiply, 126 times 32. And what do I get? 4,032 x to the 4th. Now what's different between this one and the last one? This one wants the whole term. So my answer is this whole thing. Because it wants a term, that's my answer. What questions do I have? Questions?
No, we're talking about what you know.
Oh gosh. Alright, I'm gonna have you do these two problems on your own. I'll do them on Desmos. These two are it. Yep. Alright, you are doing 9 and 10. Go. 9 and 10. Say it again. 8-4? You sure you want me to do 8-4? He wants me to use Desmos is what he's asking. But I'm making sure he wants me to do the right one. What do you want me to do? What do you need me to do? There you go if you don't have Desmos up and you need to see that.
No, someone said if they can't do it, I should probably do it. Like, who do you think you are, bro? Who do you think you are comparing yourself to me?
That's not
We're using binomial.
That's just if it was doing the combination. Like if it's
Crazy.
if it has no coefficients. Because these have the ability to do that changes.
All year.
Does that make sense?
Can't be LTS class.
You're almost out. Just a week. Actually, no more wait for you.
I mean, you're gonna use the combination here how we do the extensions too.
Well, I do not want to have
Then
anything.
we also use the combination.
I'm literally gonna solve my majors as I know how to.
So like in the book on all here, it's just like they have
Yeah,
no-
then when you meet
you have to look at
all
them.
Not that party.
at the party,
She was in a dress.
she had a dress on.
I'm pretty sure she did.
I-
That was third and
Next
series. With like
Yeah, I'm gonna do the third, I'm gonna do the terms that we have. And I'm gonna show you a formula that you can use.
Yeah, Lauren's always like that.
Okay.
Lauren's always hating about everything.
All right. I want to talk about something real quick. Be careful with these two problems. Do you see how this wants you to find x to the fifth and this wants you to find the fifth term? Those are two different things. All right. So if you are doing this right here, how do I move that off? If you're doing this right here, this would be, do you agree I'm starting off with the eighth, x to the eighth, x to the seventh, x to the sixth? Do y'all see what I'm doing right here? Do y'all get what I mean by that? This right here would be 2x to the eighth, which would give me x to the eighth, x to the seventh, x to the sixth. This is what I want. I want this one because I want 2x to the fifth. Is this the fifth term? No. What term is this? So just be careful. Just because it's x to the fifth does not mean it's going to be the fifth term. All right. And then this is going to be, what's up top? 8. What's on the bottom? 0. 1, 2, 3. Also, you could subtract those to figure that out. And what's it going to multiply by? -1 to the third. 8 choose 3. I posted it on the board. Was 56. What is 2x to the fifth? 32. Oh, 32x to the fifth. And what's -1 to the third? -1. Y'all, and then put that in the calculator. And what is 56 times 32 times -1? Don't forget that -1. Times -1 is negative. What did I do wrong? Oh, I wrote 31. I'm like, that's not what I got last period. Okay, there we go. -1792 is my answer. Am I going to write x to the fifth? No, I would be fine if you wrote it like that, but then what do you need to box? The number. Do not box x to the fifth. I just want the coefficient. That make sense? Yes. 56, when I put this combination in the calculator, I had done that while I was walking around. When I put that 8 choose 3, I got 56. Yeah. In just a minute. For my last one here, I want to find the fifth term. So 1, 2, 3, 4. This fifth term. The fifth term is going to be, what'd you say? 6 choose 0, 1, 2, 3, 4. 6 choose 4 is, whoa. It is 15. So 6 choose 4 is 15. What am I going to put first right here? 4x to the, how do I know what power it's raised to? To the 2. You could either say 6, 5, 4, 3, 2, or what could you do to these two numbers? Subtract them. And then here it's going to be 3 to the 4th power. What is 4x squared? what is 3 to the 4th? And put that in the calculator. Did I do that too fast? 16 times 15, what was the other number? 81? 19,440, holy cow. But what does this ask for? The term. So what do I need to include on this one? Include x squared. Real quick, I want to show you. Can I change this? This is the actual formula that you can use to find any term. Exactly. I know a lot of y'all look at this and you're like, nope. But this is what we've been doing. Don't you agree? Whatever number's right here, we subtract them. Hasn't that what we've been? Yeah. So it's what we've been doing. It just looks a lot confusing versus I hope this simplified it for you. All right. What I need you to do right now is y'all have about 13 minutes. You should be able to finish the evens. 2, 4, 6, 8, 10, 12. Can you give y'all 3 of that? And Sean, can you give one to Sean, please? You should be able to finish this whole paper so that tomorrow all you're doing is bookwork. Tomorrow is going to be a homework day. On Thursday, you all have an assessment in here over this. All right?